Okay, so I have a problem here. I'm going to look at the one proportion z-test and one proportion confidence interval. So in the problem here, I have a random sample, 100 students, 57 have eaten pizza in the last 24 hours. Can we conclude that the population proportion is greater than 0.5? So one of the things you can do, if you have a test you want to use, and the test for this is called prop.test, put a question mark and then put the command, then you can get a help screen over here on the right. Sometimes they're, I have to say, helpful, and sometimes they're not. But at least in terms of reviewing the kind of things that you need to put in, the arguments for a particular test, that gives you some things right there. Well, anyway, it says prop test x and p equal null. So x is just the number of yes responses, so that's 57. N is just the sample size, that's 100. And we want to know if it's greater than 0.5, so our alternative is greater than with a p of equal to 0.5. And so we can run that. Now, if you compare this to what you might have gotten on your calculator, it won't be the same exact answer. That's because the R uses what's called the continuity correction, which is the same thing we did. Remember the 0.5 on either side of an x value in the normal approximation? Well, we did it in. R uses it here as well. But if you'll just put correct equal false in that same statement, so just copy that prop test 57 100 point and so on down here and add correct equal false, then run that and you will get the same number as your calculator. Now, there's one other thing you might notice. I know I'm moving kind of fast, but you can pause. Is that the confidence interval they give you here goes from 0.488 about to 1, but that's not really the kind of interval you will get when you use your calculator or work things by hand. That's because when you have a one-sided test, R produces what's called a one-sided interval. It only goes in one direction. So to counteract that, you have to use a two-sided test, and you can see down here at the bottom, and I'll bring that on up a little bit, that I have prop test 57, that was x, 100, p equal 0.5. Now I've changed the alternative to two-sided, and the confidence level to 0.9, that has to be between 0 and 1. And I went ahead and left the correct equal false there. And I have a confidence interval. And as I've stated here, the interval is still going to be off a little, and that's because R uses something called Wilson estimates that actually do provide more accurate intervals, but we're not going to use those in this class. So just know that R's interval is probably a little more accurate. Accuracy might not be, it's a lot more likely to be an actual, in this case, 90% confidence interval. Turns out that the formulas we've been using will overestimate confidence by just a bit. Okay, so one other thing here. So that's just starting with, you can just directly enter in your x, n, and your hypothesis and your alternative correct, two-sided confidence interval. So that should cover, I think, number 1 on your homework. The second one, you start with a data set. And I've already read a data set in here. It's a student survey. And one of the variables in there is whether or not students smoke. So, in fact, I could go over here and put names. I'd usually do this in the other screen. Again, yours may, if you haven't adjusted, your screens may be in the opposite order of mine in terms of top and bottom. So there is a variable in there, smoke. It's whether or not a student smokes. And so I'm just going to, since it's a categorical variable, I'm going to make a table. And you can see that I have 42 yeses and 298 nos. So if I'm looking at the proportion that smoke, that's 42. So I just put in the x. And the total, n, is just the sum of those, 42 plus 298. And I want to know if, I said this, let's say I want to know if the proportion that smoke is 0.1. Let's say I want to say if it's greater than 0.1, then I would put alternative equal greater And if I wanted to have that, I'll just leave it like this. You could just, as above, put the correct equal false on there, but we've already done that. I just want to show you that it works. And that should be enough to get you to the enough to do this homework assignment.